Hey, welcome to a new programming day. Yesterday we worked on modules. You learned that you can split your code across different .py files, and then you can import a .py file from another file. Now, usually what you import is the script which has your functions, which does the processing. And then the main script usually is the one that produces the interface, so the command line actions. And later on you'll see that we will build graphical user interfaces with text boxes and buttons, widgets. So in that case, you will also split your code across different files and you will keep the code which produces the graphical user interface in your main.py file. So you saw that you can import a file using that statement, or you can import features of that file using this statement from the file name without the .py extension import, and then you write the functions or variables, whatever you need to import from that file. Now this line is currently deactivated, so we imported functions using this import function statement here, and then we refer to those functions in this code using functions.name of the function, and we call that function as we normally do. Of course, we always refer to the name of the module. Now today you're gonna learn something new about modules. Basically, you learn how to import modules written by the Python developer team. So more about that in the next videos. I'll see you there. Hi, welcome back. In this video, we will continue building our application. Specifically, we're going to add this message to the user output. So when we run the program, we first will show the user the current date and time. As you see, now it's May 28th. That's the year, and that's the hours, the minutes, the seconds. So that's a timestamp, and then we show the normal message to the user asking them to add, show, edit, complete, or exit the program. So how can you find out the current time with Python? Let's find it out. So I'll open a Python console. So can you guess how can we do that? Maybe a date function? No. Maybe a time function? No. So there is actually no function available in the global namespace. So for example, you can just say print and you get the output. So print is available in the global namespace of Python, but certain things such as finding the time or maybe opening a CSV file or an Excel file, these things are not included directly in the main namespace. The solution is to import such functionalities. So I know that to calculate the time and the date, you can use the time module. So this is a standard module. This is a local module, functions. It is local because it's something we created and it is located in the local project directory. So we can simply import it like that. Now the time module is also a module, so it contains code just like functions does, this module, but the time module is located somewhere in the Python installation directory. So it was written by the Python core developers, not by us. And so therefore this time module has some functions written inside. So if you are on PyCharm, you can kind of see these functions if you right click and then go to implementations. And so here you will see, for example, several functions. It happens that the time module is written actually in C language, therefore these functions, they look like Python code, and they are actually Python code, but they are basically empty. So they are fake, so to say, but still these are functions. Now, if you scroll down, you'll see something called strf time. Now, this function, if you try it in your command line, in your console, Python console, or in the code, so I'll try in the Python console first. Of course, I first need to import time here as well, just like I did in my script. And then if I do time dot strf time, strf time means string from time, and if you press enter, first you'll get an error because strf time takes at least one argument, so it is a function. Functions do give you this error when they want at least one argument. So you can see that in time.py, strf time needs this format argument to be provided. So if I provide this argument now, this needs to be a string. You see here, it says a string. And for example, if I type in %y, a capital Y, inside the quotes, and I press enter, I get the current year, 2022. If I want the month as well, I can say percentage small m, maybe make a space, maybe make a dash, whatever you like, and you're going to get that format. So percentage m turns into the actual number of the month. And every other character, such as a space, a dash, another space, these are interpreted as literal characters. So they are printed as they are. And then percentage y again is a special character. It gives you the year, the current year. So likewise, you can say percentage b, and then you get the name of the month. So we could continue this percentage b, and then the day with a lowercase d, space, or a comma, and then the year. And then for time, you want to do h for hours, maybe a colon if you like, or a dash, whatever you prefer. I would use a colon to separate the hour by the minute, capital M, with a percentage symbol in front, of course, a colon, and then lastly percentage S. Press enter, and that's what you get. So each of those format codes is converted into the actual date and time. To see a complete list of format codes, you can go to your browser, just search for Python datetime format codes on Google, and then go to the python.org website. Click on there, and then down here you'll see this strf time format codes. Click there and you'll see these results. So there's a table here. All these are the format codes you can use, and you can see the description, what you get from each of them. You can use any of them inside that strf time function. Right, so let's quickly implement this, and then I talk about standard modules a little bit more. So I'm going to copy that, go to main.py, and I'm going to store this result into a variable. Now this is a string, notice the single quotes here. So what you get in return is a string instance, which has a type string. So what you can do now is you can just say print, you can say it is, and then the other variable argument of the print function would be perhaps now. And if you print this out in the command line, you're going to get it is from that, and then that from the now variable. So that's the new feature we want to implement. Quite simple, but you now know what standard modules are. For a complete list of standard modules in Python, you can see this page. You can find the link in the lecture resources as well. Or you can search on Google for Python module index. So here you'll see different modules which do different things. So not everything is available in the Python main namespace. So you have to import some modules, and they have their own functions inside. These modules are not immediately available because the Python session would become quite heavy if you included everything. So if the Python team included everything, then they would slow down the language. Therefore, you just import what you need, and that keeps Python efficient. So for example, you have a module for CSV, so that would help you handle CSV files in Python. You can open them, you can write data in CSV files. Now, the good news is that you don't actually need to go through any of these modules. Whenever you have a problem at hand, you need to solve, you need to program something, you need to create something, then if you don't know what module to use, then you just do some search on Google or ask a question in a forum, but the search itself will bring up some results, some forum results also, where you see the community, what they are suggesting you to use. And then you can just search for that module on Google, go to the documentation page, which is if you click this module and you go to the documentation page, or you just search for some examples from blogs. So the idea is that once you know how Python works, then you can orientate yourself, you can find the way to learn any kind of module, so to program anything. You know what a function is, you know the data types, what they are. You know that you need to provide some argument to a function, which could be some file path, etc. You know that functions give you output. So no matter if that function is your own function, which you created as we did with those functions inside functions.py, or maybe someone else created that function, it doesn't matter, you can still use it. So the idea is that most of the time for the problems you have at hand, you will probably find a function that does that. So as we did here, for if you want to get the time, to find out the time, you don't have to create your own function. That function might exist, but for more custom things, such as reading a file, getting the data in a list and then returning the list, then you need to create those functions. So functions.py and time.py are both modules. And you can use the dir function actually with any of those modules. You can use the dir function for time, and you'll see the functions you can apply with the time module. I'll explain what these are as well. These capital letter names. So similarly, I can import functions here in the Python console, and I do dir functions, and I get, again, here are the functions of my functions.py file, write to dos and get to dos. Now these clock monotonic row, these are actually variables defined in time.py. If you go on top of the file, scroll down, yeah, so these are some constants, some values which are used down here in for some from some functions. So it's common practice to define the values of those variables in here. We could do the same for functions.py. For example, actually we could define here a file path variable. So these variables which hold these constants are usually written on top of the module, and they are written in capital letters. So in this case, we could put todos.txt here. That would be a good thing to do, because then we can just say file path in here and the same in here. So the benefit of this is that if we decide to change the name of the file later on to another name, then we can just change that name in here as well. So if we decide to change this from todos to todos item, then we can just write here todos item as well. So we don't need to change that in here and here. That would be enough in one place, and the variable would transport it to every other place. So let me make a break line here. Now, if I do dir functions again, you might expect file path to be there, but it is not, because you need to close the Python console and to open it again so that there is a refresh of the session. Now, if you do import functions and then you do dir functions, then you'll see file path there. So I hope that makes sense. And that was the video for this lecture. Thanks a lot, and I'll talk to you later. Hi, and welcome to the code experiments for today. Today I'm going to introduce you to 4 important modules you really need to learn, because it's very likely that you will use these in the future. These modules will be the CSV module, the glob module, and then we scroll to the very bottom, the web browser module, and lastly the SHOTL module as well, which is this one in here. We're going to start with the glob module. Here in the module index page, you'll see that this is about path name patterns. Let me demonstrate you exactly what you can do with glob. So I'm going to create a new e1.py file, and I'm going to create the first experiment here. Import glob, and then my files is going to be equal to glob.glob. So glob is the module and glob is a function of that module. If you right click and then go to implementations, we're going to see that there is a function here. This function returns a list. Let's see what this list is going to be. Now this glob function requires a pattern, and this comes as a string. So here you say what files do you want to filter, what file names do you want to filter. So if you want the text files only, you do an asterisk .txt and then print out my files, that's the variable, run the script, and you get a list with all the text files. This is very useful when you have multiple files in a folder and you want to perform something to each of them, so maybe you want to loop over them. Let's expand this example to demonstrate you exactly what I mean. Let's say that you have a folder named files, and inside files you have an ideas.txt file, a projects.txt file, and that's it. So please create a files directory and put 2 text files ending with .txt in that folder. So now let's suppose that we want to write a program which prints out the content of all the text files in that files folder. So there could be 100, 1,000, 2,000, 1 million files. Python would be able to go through all of them in just 5 lines of code. So let's write those 5 lines of code. Once you have a list in here, so let's create the list again. This time would be files / everything with txt run, and you get the file names now. Everything else, if we had some other files here, they would be filtered out, so we only get the txt files. And then, instead of printing this out, we could iterate for file in my files, or to be more clear, you can say for file path, because these are actually file paths, they are not files. So we're iterating over the file paths. With open file path in read mode as file print file.read. Let's put some content. Content 1 here, content 2 here. Go to e1.py, right click, execute, and that's what you have. So you can access the content of all the files now, all the text files in that folder. Of course, we simply printed them out, but you can do whatever you like. You can capitalize the content. You know, you get that capitalized version of the content, etc., and so on. So that is the code to get a list of file paths that satisfy a file pattern, and then you can access the content of each file using a for loop, and inside the for loop you apply the open function to each file path contained in that list. Let's move on with experiment number 2. I'm going to right click over the project directory, the root directory, and create an E2 file. I want to introduce you now to the other module, CSV. CSV is able to process CSV files. What is a CSV file? Well, let's create one. I'm going to right click over app1, go to new file and create something like weather.csv. A CSV is basically a text file with a CSV extension, and this text file is usually split in columns. For example, let's say we have a station column and a temperature column. And you could have more and more columns, such as date and precipitation, etc. But let's keep it simple. Let's have only two here. So station, let's suppose we have data for Kuala Lumpur and which is 45, and New York 20. So all these data now in a CSV file, they should be enclosed in some characters. Double quotes is advised, so you have every element, every value enclosed in quotes. Although these are not necessary, it is recommended to have them because you see these commas, these denote the split between the two columns. So station has these values, that New York, and temperature has these values, 45 and 20. So now that we have this CSV format, you can have as many rows as you want. Usually you will get these files from somewhere else, some observation stations which process these files automatically, so you might download them from somewhere and then you use Python to open them. So let's use Python to open them and to see the data. Once you import OpenCV, you want to open your data file, which is weather.csv in my case, because this is located here in the project directory and E2 is also in the project directory. So with open weather.csv in read mode as file, data is equal to list csv.reader file. So what I did here is I opened weather.csv as a text file. So you have already learned this line of code, what it does. So we have that file object now. It's in memory. And then this part here, this reader is a function of the CSV module. And this reader function expects a file object as input. So we create that file object using the open function, and then we supply that file object to the reader function. And this will give us something called an iterator object instance. Iterators are also types in Python, but this iterator is not readable, so we need to convert it into a list type. So with that, we're going to get an actual list and we store it in data. Let's then exit the block, the with context manager block, unindent and print out the data and run. And that is the output that we get. So this is a list of lists. And each of these lists represents one row. So we've got station temperature as the first row. You see that the CSV module is able to split each value of the column. because it knows that there is a comma there, and it also knows that each value is enclosed in double quotes. Now, how can you use this data in real life? Well, you could actually create here an algorithm, and we will do that now, to access the temperature of a given value. So let's suppose that the user will enter a city from the list of cities that are available in our file, of course. Otherwise, we cannot return the data we don't have. So let's say the user enters a city here. Then what we do is we iterate for row in data. Now, if I print a row here, let's see what we get. Say New York. It has to be with capital N and capital Y, no spaces after York, so otherwise you'll not get a match when we write the code now in just a minute. So for row in data print row, we get access to each list, but then instead of printing the row, we say if row 0 is city, print row 2. I'll explain what that does. Enter city, New York. And I've got this index error, list index out of range. Oh, this should be 1. I'll explain you in just a minute. Let's try New York again. And we get 20. So 20 is the temperature for New York. What did I do here? Well, we iterate for row in data. So row will be a list, because data was a list of lists and each row represents a list. Let me put this here on the side while I talk to you. And row 0 accesses the city, so Kuala Lumpur, New York in each iteration. So also it matches station, but we can avoid that by saying only iterates from 1 to everything. So for row in data 1 to everything, and let me show you how the data look like here. So you see it, print data, run. So that's how the data look like. Now I'm going to show that code again. So data 1 to everything gives us this part only. So the list, actually the list of lists, but without the first list. And then what we do here is we say if row 0, so in each row will be a list, so we check the first item of each list. The first item is always the city, Kuala Lumpur, New York, and so on. So if that is equal to the city, to New York, for example, then we say print row 1. Row 1 means this number, because the row is that list and row 1 is that, or that, whatever matches this condition. So that's how it works. Experiment number 3. E3 is about the shuttle module, which stands for shell utilities. So with shuttle you can copy files, you can create zip files, you can extract extract files from zip files, etc. So let's try the shuttle.make underscore archive. So this is a function of shuttle, and it expects as output the name of the archive you want to create. So we will get these two text files and we'll create a zip file with these files inside the zip file. So we give the name of the output file. We say that this is going to be a zip, so we don't need to say output.zip. We just tell that here. And then finally, we declare the directory where these files are located. So it's important to have the directory with only the files you need to put in that zip file, because all the files of that directory are going to be included in the zip file. And that's it. Run. And here in the same directory with E3, I've got this output.zip file created. It's as easy as that. Let's go forward with experiment 4. Import web browser. And what we're going to build here is a Google searcher, basically. So we're going to receive a search term from the user and we're going to open the browser searching for that term on Google. So let's say we ask the user to enter a search term. Right, we get that search term, we store it in user term as a string, and then web browser has this open function. The open function expects a URL as a string. So if you say here https://google.com, and if you run this script now, first enter a search term, let's say anything, so this will open Google. You see google.com because that's the URL here. But now we want to integrate the term of the user. We want to integrate it with the URL so that here in the search box that user search term is displayed. And the way to do that, to accomplish that search, is first we need to know the search URL for general searches. For example, let's say you want to search for Python website. When you press enter and then you go to the browser URL and you copy that URL in your browser and go to PyCharm and paste that URL in here, and then you will want to delete most of this. So we're only interested of up to, you see we have google.com search $Q is equal to Python website. Then that's a search term. So after Python website I want to delete everything. So that is the URL we actually want. I'm copying that and pasting it here. So if I run this, we still haven't implemented the input function, so just put anything there, press enter, and it searches for Python website. But now let's make this dynamic, so instead of Python website, we search wherever the user wants here in the input function. So I want to remove this Python website part and leave it at Q is equal to, and then I want to say here plus user term. Let's try this. User term is Python, and it's successful. So it searched successfully for Python. Let's try another one. Python official website. Press enter, and it's successful as well. So that is how you can implement a simple browser search program. Now obviously Python official website is with spaces, but still these will work. If you wanted to replace the spaces with pluses, you could do that by using here a replace method. It's a string method since this is a string, so replace a space with plus, and things would work the same. Python website, it searches for Python website. So that's about web browser as well. So those were the 4 modules I wanted to introduce you to. Thanks a lot. See you later. Welcome to today's bonus example. By the end of this video, you will have some real Python superpowers. You're going to learn how to work with one of the most important data structures, and that is JSON. Today we're going to build this Quiz app, which works like this. So you see the command line interface, that's the output of the program. So once the user runs the program, they are asked several questions, the quiz questions. So that is the first question, what are dolphins? And then you have several alternatives. We show to the user, each of them is numbered, so the user can enter a number here. For example, if they think 1 is the correct answer, they enter 1. In this case, 3 is the correct answer because dolphins are mammals. So you can press enter as a user, then you get asked the second question. What occupies most of your surface? Let's put the incorrect answer this time, which is 1. Press enter. And so this quiz happened to have only 2 questions, but you can add as many as you want. So that is the output of the program. The program lists all the questions and it tells the user if that question was a correct answer or not. So that first question was correct. So you see this correct answer here. And then it says that the user entered option 3 and the correct answer was also 3. Then you have the second question about the Earth's surface, which was incorrect because the user answer was 1, but the correct answer was 2. And then we show the score to the user, which was 1 out of 2. So 1 correct answer out of 2 total questions. So let's build this app. Let's create inside bonus a Python file, bonus15.py. Right, that is the file. Now, whenever you want to build a program, you first want to think about the output. So once you have a clear idea of what the output will be, then next is the data structure you want to use. So now you know what the output will be more or less, because I showed that to you, so you have an idea in your mind. Then you want to think about the data structure. So are you going to use a list to store those questions, or a list of lists perhaps? How do you do it? So that is the big question you ask yourself in the beginning. Now you know that we have used lists for to-dos, so we had this kind of to-dos, and we get those to-dos from the text file, and we create a list data structure in Python. So we had like buy grocery as an item of the list, and then the next to-do clean the trash, and so on. And then you also saw that we had this other example where we worked with CSV files. And there we had this list of lists, right? So like that, and then we had a second list inside that bigger list. So each of the lists represented a row in the CSV data. So that was the first row, and then the second row with two other files, and so on. And this list of lists was also generated from that CSV file. The problem now is that our data structure is a bit more complex. It is not as flat as the todos.txt file or the CSV file. It is a bit more complex and it looks like this. So we're going to have several questions. Let's say question 1, and then we have question 2, and so on. So question 1 contains these attributes. It contains the question text, and that's its value. For example, what are dolphins? Then it contains an alternatives attribute, which contains several values, which could be a list, so alternative 1, alternative 2, and so on. And then it contains another attribute, correct answer. So these three attributes make up a question. And every question has the same structure. So let's think of the data structure from top to bottom. We have several questions. So the question is the topmost object. And so we have several questions. Since each of these objects is a question, as I've told you, as I've explained to you before, when the objects are similar, you can get away with a list. So each item of the list is going to be a question. But the question is not just a string, right? It is a nested data structure. So a question contains three elements, as you see here. Question text, alternatives, and correct answer. And each of them is not similar now. So we cannot have a list where we have, let me keep that open there. We cannot have a list where we say question text like that and alternatives and so on. It's better to have a dictionary where you say question text and its value is what are dolphins. Now you might ask, why am I writing the data in a Python file? Because I explained to you before that we should store data in external files. Well, we'll do that, of course. But first let's write it here, and then we just copy and paste it in the JSON file, which I'll explain later on what it is exactly. So that is the question text. What are dolphins? That's a question text value. So a key and a value. So that is a dictionary. Now this dictionary is also going to contain an alternatives key, which is going to contain as a value these four alternatives. So one is amphibians, 2 is fish, 3 is mammals, and 4 is birds. And lastly, we are in the same dictionary. You see here the brackets. Lastly, we're going to have the correct answer key, which is going to contain as a value just a number. So 3, which points to mammals. And just like that, we're going to have other dictionaries. So let me copy that dictionary, paste it here. So we have two dictionaries. I'm going to remove this last comma. We only have two dictionaries. So question text for this one is going to be what occupies most of the Earth's surface. I've got a typo here. The alternatives this time are two, just land and water, and the correct answer is number 2. So water occupies most of the Earth's surface. Now we can do some improvements here. Here we can have a space, and here as well. Here as well. So just after the colons, it's better to have spaces like that. And I'm going to even split here and here as well. Here and here. So that is a list of dictionaries. Now if I run the code just to see if we've got any errors, no. So it seems like the list is complete. So let's store it in a variable a and print a. Execute. Yeah, it looks like this. So that's our data structure. Now, it's not a good idea to have the data stored in a Python file. So what I'm going to do is I'm going to go to bonus, the folder where my bonus 15 file is. And I'm going to right click and go to new file, questions.json. So what I'm doing is I'm creating a text file with a .json extension. Although you could also leave it as a .txt extension. So both would work, but the convention is to use .json. And inside .json, you copy and paste that data structure. And inside here, you want to get that list without the variable, so delete the variable. So get the entire list of dictionaries, go to questions and paste it there. Now we go to bonus 15, we delete that, we import JSON, we open the questions.json file in read mode as a file. We load the content of the file in a content variable using file.read, not read lines, just read, and that is going to give us the content as a string. Right? This is a string. Note that it is a string, and that makes it very useless. But that is what the JSON module is for. So instead of working on a string, we create a data variable and we say json.load_s, which means load string. The string is content. Now print data is going to be a list. You can prove that using type data. And if you check before that type content, so you're going to see that the first is a string, so content is a string and data is a list. So by having a list, that means now we can extract the items of that list, which is not possible when that structure is just a string, it's just a plain text. So now we have the data variable. Let's go ahead and build the program. For question in data, so we iterate over the data list, which is a list of dictionaries. and we say print question text. Let me keep the questions data open here on the right and bonus 15 here on the left. So if I run this, this is what we're going to get. What are dolphins? What occupies most of the Earth's surface? So we were able to access these values. It is as easy as that. So you iterate over all the dictionaries. So question is going to be the dictionary in each iteration, and question text is going to be this value. So we print out that value in each iteration. We need a question mark in here after surface. And next, so after what are dolphins, we also want to print out the alternatives. For that, we say for alternative in question, how do we access alternatives? So question, again, don't forget, question is always the dictionary in the loop. And so now we go and we say question alternatives, print alternative. So that variable, we print it here. I've got the typo. Yeah, that's correct. So this is a nested for loop under this mother for loop. So let's run this. And there we go. What are dolphins, amphibians, fish, mammals, birds? And then we have the next question and so on. Or let's improve this by saying for index, alternative in question, enumerate, print index, a dash, and then the alternative variable. Run. There we go. So option 0, amphibians, 1, fish, mammals, etc. And if you like, you can say index plus 1 to increase those numbers by 1, since the default index starts from 0. So now we have 1, 2, 3, and so on. Next, we want to ask the user what is their choice, what they think is the correct answer. So for that, we want to go under the main for loop. So just here, because we want to show that output for each iteration of the question objects, right? So don't confuse that with this, but you have to be here. You don't want to ask the user for each alternative. You want to ask the user for each question, and that brings you here. So we say user choice is equal to input, enter your answer. And we're working with integers here, so I'm going to convert this into an integer, because you see that these here in the JSON data, these are also integers. 3 and 2 are integers. So that's what we do. So let's run this. Yeah, we get the first question, and then the user enters an answer like 2, and then the next question, the answer, and the user enters another alternative like 1. And yeah, it's fine, but what do we do with this variable now? Well, there are different ways you could think of this problem, what to do with the user choice value, but a recommended way is to inject that value into the current data structure. The current data structure is stored in the data variable, so it is a list, and therefore what you could do is you could add another dictionary to this question object. So just like we have the question text dictionary with the question text key and value, and then you have alternatives with alternatives as a key and the actual list as a value. So we also want to add a fourth dictionary here, which would be something like user choice and the actual number that the user entered. And as you may know, when you have a dictionary like A is 1, and if that dictionary is stored in a variable X, you can add more items to that. For example, U is 2. So X, U is 2, and now X is updated to that. It also has U as a key pair, so U2. We can do the same here. We can say data. Actually, it's not data, it is question, because data is the entire list and question is the current dictionary. That one, for example. So question points to that dictionary. Therefore, we say question user choice is equal to user choice. So that is a string. Don't confuse that string with that. That will be the key of this pair, and that number is going to be the value of that key. So if we do that, and if I print data now at the end, after the loop ends, so I unindented here, and run, and we say enter your answer 2, enter 3, press enter. Now we got this printed out from that line. So we have the question text, what are dolphins, the alternatives, the list here, correct answer 3, and then we have the user's choice 2. So this user's choice pair was added to the dictionary. Now we want to calculate the score. So we start with a score of 0. So when the quiz has not started yet, the user has a score of 0, correct? Then, once we get the user's choice in here, we compare that user choice with the correct answer, right? Using an equality comparison operator. And then here we say a colon. So if the user's choice is equal to the correct answer, score will be equal to score plus 1. So the actual number, which is 0 for now, plus 1, and we're going to be having a score of 2. And then the next loop will come, and then if the user's choice is again equal to the correct answer, so if the two numbers are equal, then the score is going to increase to 2, because the current score will be 1, so 1 plus 1 is 2, and score will be updated to 2, and so on. So let's print the score here to check if we're doing well around bonus. Let's enter 3 for mammals and 1 for land, and there we go, we have the score of 1. Of course, we can improve that by saying print score, a backslash, and then the length of data, and run. 3 for mammals, 1 for land. There we go, 1, 2. So 2 is the length of the data, basically the number of questions we have in the quiz. Data is the bigger list. So the list has 2 dictionaries. One dictionary for the first question, a second dictionary for the second question. Now we are done with that loop. So we ask the questions, we get the answers, and then we show here the score. But we also want to show what answers the user made, and then so that the user can see what they chose as a correct answer and what the correct answer actually was for each question. Now we can print out this data here, but these are not very user-friendly, so we want to parse them now to make them more readable for the user. Therefore, we want to iterate for a second time for question in data. This time, of course, the iteration will occur over the updated data with the user's choice inside those data. So for question in data, question is the dictionary. We want to create a message variable, which is going to be an f string, and this is going to contain question user choice. This user choice now has to be in single quotes because the outer quotes are double, so you cannot use double quotes inside user choice as well. So you can say that your answer is that, maybe a comma outside that, and then go outside these curly brackets, and you could say correct answer is question I'm going to split this here, and that will create that backslash, so it allows me to split the f string. So the question at this point is going to be correct answer. So that reflects this here. Right, I have these quotes here, which shouldn't be there. So now it's fine. So quotes here, double quotes here, double quotes here, F here as well, and double quotes in here as well. So if I print the message now, answer 3, answer 1. So that's what we get. Your answer was 3, correct answer was 3. Your answer was 1, correct answer was 2. So that was for the first question, this was for the second question. Of course, you could also integrate the number here. To get the number of the question, you do enumerate here. You say for index question enumerate, and then in here you want to place index plus 1, maybe a dash. So that's gonna be replaced by the number, by the index plus 1. Since indexing starts from 0, we add 1 to that. So 3, 1, there we go. Let me delete that print data so we don't have that line there. So try again to run it. 3 and 1. And yeah, that's the result. Lastly, if you wanted to add here like a decision whether this answer was correct or not, you would have to write here a conditional. But the conditional is this one in here, so we don't have to write it 2 times. We just cut it from there and paste it in here, and then the score we also bring it down here. It makes more sense. So we calculate the score in this second iteration, and then we say under this if conditional, we say that we increase the score by 1, and then we say the result is correct answer. So if the user's choice is equal to the correct answer, we create a variable equal to correct answer. Else, the result is wrong answer. And then at this point we're going to have either wrong answer for the result variable or correct answer for the result variable. Therefore, we can integrate that result string inside the f string. So just create another placeholder here, result, maybe some space, run, 3 and 1, and there we go. Correct answer for answer 1, because we gave 3 and we got 3 as the correct answer, and then the wrong answer for answer 2. Your answer was 1, the correct answer was 2. Of course, this number makes more sense to be before the results here. So 3, 1. So there you go. Those are the results, and that is the score, the final score. And that is the final product. So the key takeaways here are that for more complex data structures, you can use JSON data. So data which are made of lists and dictionaries, and they are put in these .json files, are called JSON data. So these data can then be interpreted by Python using this JSON module. So the JSON module gets the data from this file as simple text, and it converts them into a proper data structure, in this case a list. Now this square brackets could have also been curly brackets. So this entire thing could have been one dictionary made of different dictionaries. For example, let me add this curly brackets here and close it in here. And then you could have here question 1, a colon, and then here question 2, a colon, and that would be a dictionary. Oh, we need to remove that square bracket as well. So I just changed the data structure from a list of dictionaries to a dictionary of dictionaries. Now if I open the Python console and I import JSON here, and then I open that questions.json file in read mode as a file, note that my questions.json file is inside the bonus folder, so I have to write this bonus slash, and then I'd say content is equal to file.read. So content is a string, and then if I say x is equal to json.load s, so load the string content. Now x is going to be a dictionary, so type x, it's a dictionary. But in our program, data here was a list. So the data type is automatically assigned depending on the first brackets here, which could be square brackets or curly brackets. Of course, that this would not work. So if the data structure does not follow the syntax, the correct syntax, for example, these pairs don't have keys, so I just remove those keys, then things will not work. You'll get an error when you try to read that content with that loads method. So I didn't use a dictionary of dictionaries here because, as I explained to you in the beginning, all the questions are the same, therefore we don't need to say that this is question 1 and this is question 2. We just have a list of dictionaries because all questions are questions of the same object. With that, thanks a lot for following this long video, and I'll see you later. See you. This session is one of the most important videos on your learning path because today you're going to learn how to use Git. Git is a must-have skill for any programmer, no matter what programming language you're going to use. So let's get ready and begin. Yesterday, in the programming tools of yesterday, I explained what Git is. So if you haven't followed that video, please go back to the programming tool video of yesterday. So as I explained yesterday, Git is a version control system. It is a software you need to install in your computer, and then you connect Git to the project you're working on. And Git will allow you to see and manage different versions of your program, so you can see the code as it was at different timestamps. Before we go ahead and download and install Git, maybe it's a good idea that you go to your terminal in PyCharm and type in Git there. So not in the Python console, but in the terminal. Type in Git, and if you get this error or some other error, that means Git is not installed. So you want to open your browser, type in Git on Google, and then go to the git-scm page. And I'm going to show you how to install Git on Linux, Mac and Windows. On Linux and Mac it's pretty straightforward. All you need to do is this. If you are on Mac, run brew install Git. But first you need to install Homebrew in your Mac. So search for Homebrew on Google, install Homebrew, and then run this command. That should install Git. If you are on Linux, then do sudo apt-get install Git. So run that command and Git should be installed. If you are on Windows, you should go to this page as I just explained to you, git-scm.com, and go to this button, download for Windows. You have different files depending on your system, but I'll just click this first button. Click here to download the latest Git version. Once the file downloads, you can just click it here or go to the folder where it downloaded and double click it. Press yes. You can read the license if you like, and then press next. That will be the path where Git will be installed, so I'll press next. You can leave the default options as they are and click on next. Next again. I would suggest to change this option from use Vim to use Notepad++ or use Notepad. I'm selecting use Notepad. So this is a text editor which Git uses by default. Vim is harder to use, so for you as a beginner I would suggest to use a simpler text editor such as Notepad. Although we're not going to really use this default editor because we're going to use Git inside PyCharm, inside our own IDE. Therefore this option is really not important here. So click on next. The first option is fine, let Git decide, and click on next. Here this is important, you really want to select this, the default option, Git from the command line and also from third-party software. So we're going to use Git through PyCharm, therefore this is important. Click on next, next again, use the OpenSSL library, next, 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 next again. Git credential manager is fine, next, next, and finally install. And then I'll click on finish. These are some release nodes. I'll close that. And then I'll go to the PyCharm terminal. I'll close the terminal and open it up again. And then I want to try git. Press enter. If that didn't do anything, then you might want to restart PyCharm. So exit and open it again. Again, go to the terminal, type in git, press enter, and this time we didn't get that error, so we needed to restart PyCharm. So if you got these messages, that means the git command is now recognized by Windows. Right, so now we have Git installed in our system, we restarted PyCharm, and the next step is to integrate Git with our PyCharm project. To do that, you want to go to VCS, this menu here, and then go to the first option, Enable Version Control Integration. So there are different systems there. I mentioned these yesterday. Git Mercurial Subversion, we're using Git, so I'm pressing on selecting Git here. Click OK. And immediately I got these file names colored in red. That means Git is now integrated. So what does this color mean anyway? Well, this color now means that these files are not included in the version control system. So Git is not tracking these files. We need to do something to track them, to add them to the version control registry, also called a repository. So now Git has some folders somewhere where it keeps track of the files you have. So it has a list of files, it sees what files you have here, what folders you have, so it keeps track of them. And we need to tell Git now, keep track of these files. To do that, you want to do something called a commit operation. You can execute a commit operation using this green tick mark in here. So press that. Once I press that, that is going to open this window here on the side of PyCharm. And down here you see this ticking cursor. This is blinking. It's asking us to enter some description. For example, initial commit. Now this is known as the commit message. Here you want to write something meaningful and short. It is recommended to be the length of a normal sentence. So you want to describe what you did. So what we're doing here is we are creating a timestamp. We did some changes, so we created the initial project and we created a timestamp, and then we can go back to this timestamp later on. And as the first message of the first timestamp, we usually write initial commit, and so then you want to press on commit. However, when we press on commit, we get this message, select files to commit. Up here, you'll see this checkbox on versioned files. If you expand this, you're going to see all the files you have in your project directory. So these are this gitignore file, which we're going to talk about later. This was created by Git automatically. And then we have our Python files, functions.py, main.py. There are some files also from PyCharm, automatically created some settings files. And these settings files actually are things that we don't need to include in the version control system. We're only interested to include the files of our project. So what I want to do now is I want to suspend this. I will not check any of these files. I just want to minimize this and then go to the project directory, and then I want to right click over venv, go to git, and then go to add to gitignore, and then press on that add to .gitignore. Now this is asking us if we want to create a gitignore file, so we want to press on create, and now you see that a .gitignore file was created and it's here in the project directory. You see .gitignore. Now this is saying if you want to add this .gitignore file to Git, you want to press on add. So what I did is that I added this then folder to the .gitignore file. That means this folder is not going to be tracked by the version control system. So Git will ignore this folder. Similarly, we can ignore that hidden .idea folder which had all those PyCharm settings files. So you don't want that as well. And if you like, you can also ignore the bonus folder. You just name the folder name there and so on. If you want to ignore a file, for example, todos.txt, you write the name of the file. Of course, we don't want to ignore todos.txt because that is part of our project. Bonus is not part of the project. Those are separate files. I don't want them in my Git repository. So again, you want to go back to that commit window now. You can go either here at this tab, or you could go to that button again, commit, and it will take you here. Now you see that .gitignore is checked by default, and that is because we pressed that add button here. When we created .gitignore, PyCharm asks if you want to add .gitignore. We press on add. That's why this was checked by PyCharm. To add the other files, you can either check them in here one by one, or you can click on this always add option here, and those will be checked by default. I'd like to do things manually, so I'll just check everything that I know what I'm doing. So functions.py, yes. Main.py, yes. todos.txt, yes. And finally, we're ready to press that commit button. So press on commit. Here you want to specify a username, so just choose something such as Ardit and put your email address here. And then press on set and commit. Now this password and email address are only asked the first time. You'll not get asked again in the future. Press on set and commit. And we are done. So I see this message here, 4 files committed, initial commit. So we committed .gitignore, main.py, functions.py, and todos.txt. What that means is all these 4 files now are tracked by Git. That means if I go to main.py and I add something, for example, above this it is now print function, I want to add another print function, print. The time is below. Let's suppose that what I've just added is a new feature to the program, right? I added a label. That is a feature, let's say so. Anytime you add features, you want to do a commit. So you want to record that milestone. Therefore, I want to go to that commit button again, the green tick mark, press it. This window will show. Now, in here, you'll see that main.py is automatically checked. So Git automatically found out that we made a change to this file. So the next time we commit, as we're doing now, Git notices that we have done a change between the last commit and this commit, and you want to leave that checked. And you want to write a message. Add time label feature, for example. So this is how messages should look like. It's recommended to use present tense for verbs. Try to start your sentences with a verb. So add time label feature, that is what you did in this commit, and press commit. Right, then you can close this tab by pressing that tab there. And then if you go to this Git tab down here, bottom left, press it, you're going to see all the commits you have done in your project. So if you press in one commit, for example, I press over add time label feature, here on the right you're going to see the files you have changed in that commit. So that was main.py. If I double click main.py, it's going to show me side by side the current file here on the right and the previous version of that file here on the left. So you see here we don't have that print function, but here we have it. So in this view you can see the differences. But now what if you want to go back to the state of the program as it was in the initial commit? So if I press on initial commit, you see that main was like that. There was no that feature here which prints out it is time, that new label. So how can you go back to one timestamp, to one commit? That is what I'm going to show you now. So let me close that. Here is the main.py file as it is right now. So you see main.py, it's not from the revision, it's the actual file. And there are two commands which you can use to go back to a previous commit. One is checkout and one is reset. Git checkout and git reset. When would you use git checkout and when would you use git reset? Let me demonstrate you git checkout first. To do a git checkout, you can right click over the commit you want to go to. So you want to retrieve the program as it was in that commit. Right click and then go to checkout revision. Click that. Now you're going to see that that print function, which was somewhere in here, has disappeared. So now you're looking at the previous version of the program as it was when you did the initial commit. Here you'll see this yellow tag with an exclamation mark after it. That tag showed up when I pressed on that checkout option. So that means this is now the current version of the program. The thing is, this add time label feature is still a commit and it is still standing there. So the checkout command is not the actual command you should use if you want to permanently go back to this commit. So checkout is simply to quickly see the state of the program as it was. So you can also execute the program if you like, and you're going to see the output of this current state. But if you want to have the permanent changes, then you want to use a reset command. So checkout is simply to check a previous version and then go back to the master head. So the head is the latest commit. So now we are currently in here, you see the tag, but then you want to right click here after you have seen that previous state of the program, and then you want to go to checkout and then go to master. You see that now the yellow tag went back to the first commit. So now you see that print function is here again. The time is below. Now the reset command is different. If you right click over initial commit and you go to reset current branch to here, then you want to go to hard, and if you press reset now, that commit disappears. So basically you go to the previous state of the program permanently. Therefore, checkout is particularly useful, especially now that you are learning. So each day you can make a commit and you have all these commits recorded for each day. So then maybe you want to go back to a date just to check out the code, see it, run it, and then you can check out the latest branch again. So how often do you do commits in real life? Well, it depends. You'll get used to that with experience. But basically, if you add something and it works, so you make some changes, you run the code, it works, then you make a commit. The changes could be changes of the existing code or adding new code. So both could require a commit. Basically, during a day, you might have several commits, depending on how much you code. And that's it. So if I close PyCharm now, I exit, I open it again, and of course the commits are still there. So in this Git tab you can access the commit. We have only one commit now because we reset it to this commit, so all other commits are disappeared. The other commits above this commit are disappeared. So that's what you learned today. To wrap it up, you learned the commit command, the checkout command, and the reset commands. I know it's very confusing in the beginning. You have many questions, many things you are not clear of, but don't worry about that because you'll fill in those gaps as we program through the course. That's why we have many apps. We're going to build many apps and we're going to use Git along them. So you'll see me how I work in different scenarios. And by the end of the course, you'll have a very solid skill set to use Git independently on your own and understand all its features. One more thing before we close the video. Yesterday you heard me mention GitHub in the programming tool of yesterday. I didn't introduce you to how to use GitHub today because I wanted to focus on Git. So Git is the version control system. That means it tracks the changes on our local computer, and GitHub is the hosting platform. It's a cloud-based service where you upload your code to a server to keep it as a backup and as a point to collaborate with others. You can share your code using GitHub. Now, we didn't cover GitHub today because we want to take things step by step. So today we simply worked locally. Our code changes are tracked locally on our computer. Tomorrow we're going to synchronize the code to GitHub so that you know how to use both Git and GitHub. So with that, thanks a lot for following this, and I'll talk to you later. See you.